Hello and welcome to today's webinar presented by Delubal Software. Today we'll be working in our structural analysis and design software, RFEM. The topic for today's presentation is Revit, IFC, and DXF integration in RFEM 6. My name is Amy Heilig. I will be your moderator for today's presentation. I'm the CEO of the US office. I'm also joined by Siska Choa, who will be a moderator. She's a technical support engineer. And finally, we have Alex Bacon, who will be your presenter, and he's also a technical support engineer. And we're all located in the Philadelphia, Pennsylvania office. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within this same dialog box. If by chance we don't get to all your questions, we'll certainly send you a follow-up email afterwards. And with that said, I'll go ahead and turn it over to Alex for the rest of the presentation today.
Great, thank you, Amy, for the introduction. So for today's webinar, I would like to give a general overview of the following interfaces shown below. So along with some hints to some future developments that we have planned and are currently working on. So first, I would like to start off with going through the data exchange with Autodesk and Revit. And then the next portion is going to consist of going through importing and exporting of IFC files. And then lastly, we will end on importing and exporting of DXF files. So like I said, I would like to start with Revit, but before that, I want to have a closer look at the objects that you can transfer and just some general information on the integration. So currently we have the interface for Revit 2022, and we're working on Revit 2023. And this is planned to be released this month, actually. And both of these releases are set to our named work in progress versions. And what this means is that we haven't fully developed all of the features that we want to have yet, but the most important features like the import/export are working for the first release. Then the interface itself is still a direct interface, and this is based on web services. So keep in mind, Revit and RFEM must be installed on the same PC, and this is similar to the past. And then the installation is a little bit different this time. So it's a manual installation. And so once you install Revit and RFEM on your PC, you'll want to navigate to this folder shown here. And then from here, you want to run this .exe file to install the direct interface. Currently, this link/transfer requires a web services license, and we plan to make this free in the future. For now, though, if you want to test this out, feel free to get into contact with us, and we will assign you a free web service license to test. And then the last bit of necessary information is to make sure that this setting shown here under the program options and settings is turned on. And what this does is it starts the web services server automatically after you start up RFEM. And this is important to have checked on to have this direct interface working properly. So before we go over the interface itself, I wanted to have a look at or show you the objects in the list here that can be transferred from Revit to RFEM. So some standout ones, for example, are walls and slabs, along with columns and girders, so beams, and then materials and cross sections can be transferred over along with openings. So those are kind of the standout ones. And basically this is all related, these objects are all related to the analytical model data. And at the moment, we are lacking or missing on some features like loading. So loads we don't have at the moment, they cannot be transferred over yet, but they are under development and should be released soon. Next, I wanted to go over the settings regarding the export. So we can go over those here in the PowerPoint. So the first setting that you'll see in this export dialog box is that you can determine the direction of the global z-axis. So you can either choose to have this set upwards or downwards in RFM. And then we have some exporting options here. So the first option here is to create a new structure. What this will do is create a whole new blank file in RFM. Then you can also choose to overwrite an existing structure, and this will completely delete the structure in RFM and overwrite it with the structure from Revit. And lastly, we have update existing structure, and this will just update the items or the objects that you've changed in Revit and RFM. So for example, let's say you first export from Revit to RFM, and then you modify the structure in RFM, and then maybe at some point the Revit model gets updated. And with this update existing structure option, then you can just simply update the RFM model, and there's no need to start all over in RFM, and then you can save that. Then there's an additional option here. So you can overwrite the member releases, or by default, we have this turned off. So the reason for this is because we believe the RFM hinges or member releases have a higher priority. So by default, we believe you don't want to overwrite these, simply because we just have more options for hinges in RFM, for example, like nonlinearities. And then we have some additional options here for the exporting of subsystems or just specific portions of the model. So for example, only selected objects. That's if you highlight specific objects in Revit, you can just export those highlighted options, and then only visible options is pretty self-explanatory, along with only members and surfaces. Then some more additional options on the right-hand side here. So you can choose to, if you want to export member eccentricities or surface eccentricities. Eccentricities are some calculated distance between the analytical line of a beam or slab, and that distance is to the center of gravity of the physical object. So that's what an eccentricity would be in RFM. And then there are some additional options here that I'm not going to go over live today, but feel free to check out the PDF that is located in the handouts of this webinar or the recording online to read through these. The yellow highlighted options are still a work in progress and are not implemented yet. And then this add name to comment option, basically when you export, the material and cross-section names will be automatically placed in the comments of any element in RFM. And then there is a second tab called Structural Settings, and this is the last tab in the export settings. And basically what this does is it allows you to convert isolated foundations into nodal or line supports or surfaces with elastic foundations. So this will turn your, like it says, isolated foundations or wall foundations into either nodal supports or line supports or surfaces with elastic foundations. Then the next topic is conversion tables. So this is a topic that comes up with every exchange between software programs. So materials and section names must be converted between programs because the names don't match up exactly. And so with this conversion table, we modified this a bit for RFM 6 versus RFM 5. And the reason for this is because the conversion tables are now found in Revit itself. And you can see this table here shown. And the table is divided between export to RFM or importing in from RFM. And so yeah, the left-hand side is for exporting, right-hand side is for importing. And then these tables are further divided by material and section. And then they are subdivided further by whether you're using regular expressions or not. And in case you want to use regular expressions, just a little bit of information on these. Regular expressions are like parametric conversions. So for example, instead of mentioning all sections from W shapes, now you could write it as a regular expression. And then if you want to use regular expressions, and yeah, then you don't have to list all of your W shapes. You could simply just write a regular expression for it. So if you want to use regular expressions and you're not sure what they are, the best thing to do is to do some online research. Since we don't actually develop regular expressions, they are a general functionality. And if you want to have an easy way of creating a regular expression, you can use the link shown here to do that. And then the next topic is the doable parameters that are found in Revit. So with this function, you can release or add additional parameters into the analytical properties in Revit. So from the 6 that we have listed here from previously, only 2 of these right now we have working at the moment. But what you can do is now you can add a parameter for a truss type or a tension only type member into the analytical properties of a column or a beam, for example, in Revit. And this allows you to designate whether a column or beam is a truss or a tension member in Revit. So then during the export, this can be read by RFEM and assigned to the corresponding members. Just to mention, in the future, we would like to upgrade this whole feature and give it more attention. So we would like to introduce free parameters in Doable, and this option would allow you to assign additional free parameters to beams, surfaces, cross sections, etc. And then those parameters could be shared with Revit or IFC files or any other application. So this isn't planned yet, but this is planned and also, but not implemented yet. So that is the parameters that you can use. And then the last topic I want to go over before getting into the interface is the import settings. So this is the dialog box that'll pop up before, or if you would like to import a model from RFEM into Revit. So similar dialog box compared to the export settings. And you can see here, we have similar options. The only option that is available under the export options here is the update existing structure option. So it's only possible to update a Revit project. You cannot override or create a new project. And what this allows you to do is to export into RFEM, for example, modify a model in RFEM, and then update the Revit project. And another example using this option is maybe you could just open an empty Revit project and you want to read all of the info in from RFEM or RSTOB, and you can just do that by updating the project, and then you'll get all of the information from Revit or RSTOB. And of course, this is only if you want to make sure you have the correct families preloaded into Revit as well, as we're not able to actually create new families when importing in from RFEM. So then there are also some functions for controlling the amount of transfer that you do. And this would allow you right now to transfer some of the objects. This is also a little bit still under construction, but you do have the option to only transfer members and surfaces if you'd like. And then we have some other options that are also under construction still. So the options for eccentricities, which are shown here, are not available yet. And then we have some remaining options here two of them. And the first one is you can check on not to create new levels in Revit during the import. So that's available. And then also you can choose to only update materials, thicknesses, and sections. Sometimes this is a safer way of updating projects. So that is it regarding the theoretical point of view of the interface. So now I'd like to get a look at the actual interface itself. So what we can do is we can move over to Revit. And now here you should see I have an example open in Revit at the moment. This is a project that I previously put together. You can see that it is a mixed structure of concrete and steel. And maybe this is possibly some small offices here. So we have some concrete walls that are 8-inch. And then we have some concrete slabs that are about 12 inches, along with an opening. We have some concrete columns that are 8 by 8. And then we have this smaller steel structure on top using W sections. So this is a physical representation of a project. And what I'm more interested in is the analytical model, because that is what is going to be transferred into RFM. And you may be asking, how do I get this analytical model in Revit? So you can get the analytical model by checking on an option. So if I click on one of my elements here, let's just say I click on my concrete square column, you can go to the structural properties here in this panel. And then if you scroll down, you will find this option that you can check on that says enable analytical model. And if you activate this option, which I've done for all of the elements here, then Revit will convert the 3D objects into lines for columns and beams, and then 2D objects for slabs. And so if I'm converting my column, for example, into a simple center line that goes up the center of gravity of the column, and then a 2D object for my slab here, which is going to go at the halfway point of the thickness, then naturally I'm going to have a gap that is going to appear between these two lines. And so what Revit is also doing is not only converting these objects into surfaces and lines, it's also connecting this gap afterwards. So if I click on my column here and then I change it to my analytical properties, if I scroll down here, then you can see the analytical alignment settings here are all set to auto detect. So this is how Revit automatically detects that. There's also another option here in the dropdown. If you hit projection, then you can also manually set a level for how much you want to shrink or elongate the member or column. So this was all done for me, or I've done this already previously. And so what I can do now is double click on the analytical 3D model here. And this is basically what our Revit does. And you can see if I rotate the model that all of my columns are connected to my surface and they're all in the correct plane. So lines and surfaces are all connected in the same plane. My downstand beams are projected into the plane of the slab here, which is required for RFM. And this is the model that's going to be exported to RFM. And this is what the interface or plugin refers to. So if you installed the plugin correctly after installing Revit and RFM, then you should see this tab up here called RFM 6 Work in Progress. And that'll give you these 4 icons here. So before running the export, I would like to check my conversion tables. And before doing that, let's just look at some of the names here that I have for my objects. So for example, I have a W wide flange up here, and you can see the name is W6 by 20. And then I can also change this and go into my properties, and I can see I have my material set here under my properties, my structural material set. If I open up the material library, you can see the name, and I'm using steel A992 according to the ISC 360 16. And so this is the name, these are the names that, or the naming convention that RFEM is not quite aware of. And so there's different names or specific names that are used in RFEM that are slightly different. And so what we have to make sure using the conversion tables is that RFEM reads these names correctly. And this is done in the conversion tables. So if I click on conversion tables, you can see this is what I showed previously in the PowerPoint. Again, the left-hand side, I have my materials and sections for exporting to RFEM, and then the right-hand side, I have my materials and sections for importing in from RFEM. So you're maybe asking, how do I add a new entry? So to add a new entry, you want to go down here and click the new button, and then you want to decide if the conversion is going to, if you're going to be using regular expressions or not. So I'm not going to be using regular expressions, so I'm not going to check this box. And then is it related to the export? And if so, then I'm not going to click on from RFEM. And then we want to hit this drop down, and it's going to be part of Revit. And then we need to decide if we're using a material, or if this is going to be a material or section. I'm going to choose material for now. And then this custom name field is going to be the name taken from Revit that I showed. And then you want to enter in the material name from RFEM. So it would be Revit material name. And then you would want to type in RFEM material name here. And then you would want to click save. And so now you can see I have my Revit material name, and that is inserted here under material. And yeah, so that's how you can enter in material. And then you can do the same thing for sections by hitting the section drop down. And you can also see some of the examples here that I have already. So I entered in my W5 by 19 section, and I have the Revit name here, W5 by 19, and then the delubal name here along with the standard that's used, so the AISC 15. And so now what we can do is now we can run the export. So I'm going to close the conversion table, and then before exporting, we want to click on export model. And then you'll see the export settings dialog box will pop up. We can choose the Z direction. So I'm going to keep that as upward. And then I'm going to choose to overwrite an existing structure as I have a blank model open currently in RFEM. And then I also want to choose to apply my member eccentricities. And so I'm going to have that checked on for this is relevant for the downstand beams, which are dropped below my concrete surfaces. And then additionally, in the second structural settings tab here, I want to convert my isolated foundations into nodal supports. These are the foundations under my columns here. And I want to convert my wall foundations shown here under my walls into line supports. And so once that's done, I can click start. And so then the export will begin. Revit will communicate with RFEM using web services and transfer directly all of the data into RFEM, and the transfer will then end once the export says succeeded. So now we can close this box, and then I can switch back over and open up RFEM. So now you should see in RFEM the model that was exported over. So looks really good. You can see the model here. My concrete and material properties have transferred over. and I can look in the project navigator on the left-hand side under my materials, sections, and thicknesses, and we can see all of my materials and sections and thicknesses have all transferred over properly, which is good. And now what we could do is continue modeling this mod structure by creating loads and load combinations on RFM and designing the structure. But this is something I'm not going to show for today. I will give an example of, let's say, maybe we have to modify the model here because some beams are missing at the top here, or maybe we have to increase some sections because they don't meet the design. So yeah, let's say we have to add some beams up here. We're missing some beams. So if I hold Control and select all of my beams, I can hold Control and then use the drag and drop feature to move those beams over, and I can model my additional beams there. And then let's say we have to increase the size of our columns. I'm just going to increase the size of this one by double clicking on it to edit it. And then I can go to section and I can open up our material library and create a new section. I'm going to choose massive rectangular. And I'm going to, let's say we had to go from 8 by 8 to 12 by 12. I'm going to click OK and make sure my material is set to concrete for 4,000 PSI according to the ACI. For example, I'm going to click OK. And now we increased the size of this section here and added some beams. And so now let's say we need to update the Revit structure. So if I open Revit back up and I need to update this structure, I can simply go back to the graphical view, and then I can go to import model. And so now we have to choose update existing structure. We can keep that applied, and then we can hit import or start. So once that begins, sometimes you might have to assign the families again to some of the cross sections for RFM. This won't be the case in the future because we will be optimizing this functionality, so you don't have to do this, but all you need to do is, for example, for my concrete columns, it's not assigning the families, so I can go in here and choose 8 by 8, and then we have our 12 by 12 here. I can click apply, and that will be done automatically, and if the families are preloaded correctly in the future. So now we can see our new beams up here have been added to the steel structure, and also our column here, the section is updated to 12 by 12. So that is another way of, that is one way of importing. So another way of also importing a model is maybe you just have a totally blank Revit file and you want to bring in everything in from RFM. So this would be the exact same way. You could import the model and choose all of the exact same options, hit start, and then make sure all of the families are preloaded, and then all of your conversion tables are set up, and then you just have to sometimes select the corresponding families, hit apply, and then that import will go through, and RFM will simply load in all of the info into Revit. So like I mentioned before, the eccentricities are not supported at the moment, as you can see when importing, but we are working on optimizing this and implementing this for the future. And at the moment, the beams are just connecting to the bottom of our slab here. So now I would like to switch back to the PowerPoint. So that's everything regarding the interface between Revit and RFM. So now we can move into I want to go over some general information on the data exchange for IFC formats. So regarding the import for IFC, we support two versions. So we support the IFC 2x3, and then we support the IFC 4 versions. IFC 4 is new in RFEM 6, and we also can import the structural analysis view along with the coordination or reference view. And we also have an integrated IFC viewer. This is something we had in the past. This allows you to display the content in RFEM as graphical objects. And then lastly, we have the option to convert graphical objects into native doable objects. So for example, this may include an IFC beam being converted into an RFEM member, which is nice, pretty handy. Then regarding the export, at the moment, we only support exporting IFC formats from RFEM. We can export the structural analysis view along with the reference view. And this exporting the reference view is actually something that's new in RFEM 6. So now you can export your model into the common IFC format reference view. And then what that allows you to do is to open the files in any CAD software. So for example, Revit, Tekla, IFC viewers. And in the past, we only had the structural analysis view as an option. So now we can go over the workflow of this in RFEM. I'm just going to open a new RFEM model and create a new model and just name this IFC format import. And I'm going to click OK. And then also I wanted to just open an IFC file that I had previously in BIM viewer. So this model was the same model that was in Revit. I just exported it as an IFC file. And it's basically the exact same thing. We have our steel structure on the top, and it's made out of the remaining concrete structure on the bottom. And what's nice is with IFC formats is you can take a look here on the right-hand side is all of the information regarding cross-section and material that's necessary for an analytical model is all transferred over here. So for this W-shaped column here, we have a W5x19 along with the material here, A992 steel. And then this is also done for the columns and then the slabs and everything. So let's say we have this IFC model and we want to open or import this into RFEM and create a structural model or an analytical model. So I'm going to back up RFEM, and then once in RFEM and you have a new file created, you can go to File, Import, and choose IFC. And then we can simply choose the IFC file, click Open, and what RFEM does is detect that it is a reference view automatically, and it will activate the integrated IFC viewer, and this small dialog box will pop up. And so what this will do is what we can do in here is change the insert point of the IFC file. So you can either do that by manually entering in the X, Y, and Z coordinates for the global axes here, or you can choose this graphically. So I'm just going to put it at the origin. And then you can also rotate the model about the axes here as well. Along with, you are also able to switch the coordinates or mirror them here as well. So now, once we click OK, we can click OK again, and now we can see, or you can see that my IFC model has been imported. I can turn off my grid here, and we're able to use the integrated IFC viewer. And you can tell we're using the IFC viewer because now we have some additional tab here, IFC, in the navigator on the left-hand side here. And we're able to turn on and off the slabs here. So there's some visibility types automatically created. We can turn on and off the visibility of the columns along with the footings here. So you have some options for visibilities, and then you can also get even further into detail with visibility by turning off specific objects. So you can see you can turn off specific columns and beams, columns, and footings. And if we click on one of these objects, so let's say we click on the beam here, one of my beams, steel beams, I can turn on my object properties. So on the right-hand side, I'll get my basic IFC properties. And what's nice is that the information for the analytical model was carried over from the IFC file. So you can see I have my cross-section name here. And then if I go to my third tab here, I can also hit this drop down and you can see that the material name has also been carried over. So now we can use this model for the manual creation of if we want to, for our nodes and lines. That's the first method. And what we can do is use what's called object snap, which is built into RFEM. So if we look at if we right click on OSnap down here, we have our object snap settings. And with these turned on, we can basically draw our center lines and our members on our structure here. So I'm just going to do a small portion of the structure for an example. So I'm going to highlight the bottom portion here and hide these selected objects. And then I'm going to turn off the hidden objects in the background. So let's just focus on the steel portion here. So let's say we want to model this steel portion. The first option would be if we just simply use this column for an example, we want to model this column. Right now it's just an IFC object, but we want to convert it into a deliverable or RFM member. So we can turn this into a wireframe view here. And then what we would need to do is use the tool up here we want to create some nodes at the center of gravity of this column so that we can draw our line. So we want to use the tool here between 2 points. And once that tool pops up, then I can simply snap to one corner of my column or cross section and then the other one and click apply. And now we have a node placed at the center of gravity of this column. And then we would want to do this for the top as well. Click apply. And then we would want to connect these nodes here with a line. So I can simply select my node here at the center and then snap to the bottom here, right click to cancel out. And now we have our analytical center line for this column. I would want to double click on this line, go to member, and then under member here, I can create a new member, go to section, and I would want to assign a cross section and a material to this line. I can import this from our section library. So I would want to open up the section library. And then we have our standardized sections here, our W shapes. So I can choose those. And I filter to the AISC 15. I want to go to W shapes. And this specific W shape is a 5x19. So I'll scroll down to 5x19, and then I can choose the material, say steel A992, and you can get any material from the material library here. Click OK again and again. And now if I change this to a solid view, you can see that my column here is created and I can actually use this for my analytical model. So that's one way. So this is how you can turn IFC objects into RFM objects, and it might be a lot of manual work, but for this file, you could definitely do it depending on the size of your file. So that's one way of creating or turning your IFC reference view file into a analytical file in RFM. There is another method that you can do. So if you right click on an IFC object, you can right click on it, and then you'll see that there are a couple of options here for converting it you can convert it either into a straight member a curved member or convert it into a surface or solid. So before you do this though, you should check your conversion tables in RFEM. So if we go up here, if we want to go to our conversion tables, so we want to go to CAD, the CAD BIM menu, and then open our conversion tables. And so we have a conversion table in RFEM. And so here you can see my materials. So I'm in my materials tab here. And when you import in an IFC file, we try to insert the material and section names into these tables automatically. So all of these names and sections from the IFC file will be inserted automatically here on the left-hand side. But what you have to do is make sure to assign the correct deliverable material. So very easy. I already did this for my materials, but you can simply click on this edit material button here, and then you can filter to the material that you would like. For example, this was steel A992. So we would want to filter to steel A992, click OK, and then that will be, that material name will be inserted here automatically. I will do this for my sections. So all I need to do is my flanges, my W shapes here were entered automatically for me. So I have my W 6x9 here. And so I would just click on this button, go to my W shapes, and then scroll all the way down here to my 6x9s. Click OK. And then you can see that the correct name here has been entered. And then what I can do is simply hit F8. I want to hit F8 for the cell below there. So we can hit the next cell, then hit F8, and then hit F8 again, and fill out these rows here. And then for these, instead of having to go through the material library, we can simply just edit them. So I can change this to 5x19, like that. So now we have our cross sections entered for the steel structure behind this window. I can click OK. And now we can convert our objects here properly. So so you can do this for one single member. So I can right click on this member, convert it into a straight member. And now you can see it's converted. Or what you can do is you can highlight multiple members. So if I hold Control, I can highlight all of my straight members first, like so, get all my columns, and then I can right click, go to IFC model object, and convert into straight members. And so then once you do that, then you'll see once you go to edit them, that the section cross sections have been assigned to the member along with the material here. So we have steel A992 and the correct sections. So if I click OK, the last thing we need to do is do this for our curved members as well. So I can go around here holding Control, selecting my curved members and converting them, and right clicking on them and converting them into curved members. So yeah, awesome. So this looks great at first. But what we want to do is check on the wireframe. So if I turn this into a wireframe view, unfortunately, you can see that a lot of the nodes are not actually connected here. And so the reason for this is because there are gaps between the beam here, as the beam is going to end at the flange. And this is basically because of the conversion from the IFC file. If we go back to BIM Vision and we zoom in here, in BIM Vision, you can see that the beam ends at the flange of the column here. And so unfortunately, our analytical model is also going to follow this same layout here. And so this is something that the user is going to have to do manually, is connect these back. We don't have any autonomous features that can connect these lines afterwards. But this is doable, at least for this model. And we do have some tools that can help with this. So what we can do is simply select our beams here, like so. We can go around and select them. right click on them, go to members, and one of the really nice tools to get these all connected again is if we choose the extend member option and we choose under extend through, we hit to next member / line. We can click OK. And now all of our lines here are connected. So all of our beams here have been connected. You can see, so they're all connected. Then we would have to simply go around to our corners here and use our drag and drop feature to connect our curved members here, like so. And we'd also want to make sure that our surrounding girders here are connected to our columns. So there's just a little bit of cleanup work when it comes to that type of conversion for IFC. You would have to do this for the remaining 4 corners here, and also our beams here on the outside. But after doing this, then you'll have a clean converted IFC file. And so this is something you're gonna have to do if you don't want those eccentricities. It's a bit of manual work, like I said, but you get an analytical model out of an IFC file. And so that's how importing in IFC files works and how you can get an analytical file. One thing to mention, we are possibly collabing with another software company to automatically get these analytical models and optimize this conversion further. This is still in development, but we will plan on sharing more information as soon as that's ready. So now let's talk about exporting IFC files. So I have a Stadium project here that I have previously opened, and I previously created this Stadium model in a previous webinar that was related to Rhino and Grasshopper. And so what I did was I exported this file as an IFC file, which I can open now. And so now you can see the Stadium file as an IFC file. And when you export this file, if you want to export this file, you can go to File, Export, and choose IFC. And then you can save this file as anything you'd like. And down here in the right-hand corner, you can choose to export this file as an IFC file. And you export. So if you choose IFC, you can give it a name, and then you can choose between a type here. So you can choose to export it either as a reference view, which is what I talked about and it is new in RFEM 6, the reference view, or you can choose to export it in as a structural analysis or export it out as a structural analysis view. So once you do that and you save the file, then you are able to open it in any viewer, BIM viewer like Tekla or Revit, and you can get all of the content and info from RFEM. So if I go back to my BIM viewer here, all of the info from Revit or from RFEM has been exported. So if I click on my column here, for example, we can see the column here on the right-hand side, and we can see the correct beam here was opened up. So let's see. If I click on one, you can see I have my material here along with the cross-section name at the bottom here. So you'll get all of the analytical properties that you need, so material and cross-section, inside of the IFC file. So that's basically how you can export an IFC file. And like I said, you get all of the required info for an analytical model. So now let's go back to the PowerPoint, as I would like to now move into the last section of this webinar, and that is all about the DXF template or format. And so before going into the actual interface or going into the steps on how to import or export a DXF file. I would like to just go over again, lastly, some general information on DXF. So there's two options for importing in a DXF file. You can either use the direct import for AutoCAD, or you can just import in the DXF file itself. The same functions are these both have the same functions. And then there's also an option for importing in specific layers. This is something that RFEM 5 had, but now we have optimized it. So what you can do is now select multiple layers. In the past, you could only select one layer. Next, there's an option for converting lines to members using, this requires having the specific layer description shown. So you can see on the right-hand side here, you can now, if set up properly, your layer descriptions with the cross-section and material name, you now don't only get lines into RFEM, but you'll get the material and section as well. Next, you can import DXF files as background layers. So I will go over this as well. And then lastly, I just want to mention that we can only export lines from RFEM and RSTOB into DXF files. So this is the center lines from the members, and then the boundary lines from the surfaces. Something or information like the results and outlines of members is something that we have planned for the future. So we would like to implement that. And so now let's go back to RFEM. And what I want to do is create a new file. And this file I will name DXF import example. I'm going to click OK. And so first I would like to show you how to import a background layer from a DXF file. So this has changed a little bit. We can import this using guide objects, which are found in the navigator right here on the left-hand side. So we want to go down here to the folder guide objects, and then you can find the background layers. So we want to right-click on background layers and choose new background layer. And then once that opens up, you'll see this dialog box. And the first thing we want to do is import our DXF file. So I'll click on that button and locate my DXF file locally on my computer and hit open. And then there are some additional settings here. So I'd like to point out the insertion point. This is the point at which the model will be sitting on the origin. So that will be the center. There's some other options here. And we would like to optimize this a little bit further and improve on it. So at some point you can just snap to a point on the DXF file here in the graphical view, and then that will be your insertion point. So hopefully that'll be in there graphically soon. Then you can choose your origin point in RFEM, and you can enter this again manually, or use the you can use this button to choose it graphically. Then there are some scaling options here. And lastly, or second to last, you can choose your units. So you can set this to automatic, or you can, if you know the units, you can choose them. I'm going to choose metric, as this is what this model was originally modeled in metric. So I'm going to choose that. And then at the top here, you can activate or deactivate background layers. And this is helpful if you have something like a multi-story building and multiple background layers listed here, and you want to hide, or if you want to deactivate or activate your background layers. So now we can use these background layers to model this. This is similar logic to the IFC file that I showed. And I'll just do an example real quick. So we can draw a line, a center line again. I'm going to use this column again as an example, so I can zoom in here and snap to this point if you have your object snap settings turned on. and then I'm going to go to the top here and I can snap to this point, right click, and then I can double click on the center line, check on the member option to turn this line into a member, go to section, and then I can quickly go to W shapes, and I can scroll down, and this will be in 8 by 35. Click OK. I have steel 8992 assigned. I can click OK again and again. And now you can see I have my W shape here created. So this is one method for modeling in a background layer. You can just add in the center lines and then assign the corresponding cross-section and material. So that's one way. Another method is to import these lines directly. So I'm going to clear this out and I'm going to show you how to import the lines directly. And to do this, I'm going to open up AutoCAD. And in AutoCAD, you can see here I have my exact model here. And you can see I have my member lines, the outlines of my members here. And then what I've done was drawn in the analytical lines at the center of all of my members here. And then depending on the cross section, I made multiple property layers for each cross section. So here my red cross sections or my red lines are corresponding to my red layer. And those are my W 4 by 13s with the material here. And you can see the layer description. This is the exact format that you have to type your cross-section name in with your materials. So first it's the cross-section, then a space, then a money sign, and then the material name. So this is very important. Your description has to be in this exact format for RFEM to be able to read it and extract that information correctly when importing. So once you have all your layers set up properly like this, then you can go back to RFEM, and I'm going to delete my background layer here, and I'm going to go to File, and you can go to Import, and you can choose AutoCAD or DXF. I'm going to choose DXF, and then I can choose my DXF file, hit Open, and then once I hit Open, this dialog box will pop up. And again, you can choose the origin point or rotate the model. You can flip or change or switch around or mirror the axes. The most important option we want to check on is to generate our members and use layer identification. So now with these options turned on, instead of just generating the lines, I can also generate the sections and materials based on the layer description. And so now you can see those layer descriptions down here. I want to check off my member outlines in this layer. And then I also want to change my units here. And so now once I click OK, my conversion tables will pop up. And once I click OK again, now you'll see that I have imported the model and it looks really good. So if I can also check and make sure all of my sections were imported properly. So I have all of my correct W-shaped sections here. And so this is another method for importing in a DXF file and modeling it in RFEM. And this isn't suitable for everyone. You might, since you have to create the analytical lines in AutoCAD, if you haven't already done that, it might be a lot of work, and maybe you're better at modeling them in RFEM. But it might be helpful for companies that use blocks in AutoCAD. Maybe you use blocks and you use very similar structures and maybe the same type of structure all of the time. And if in your blocks you already have the analytical lines modeled, then this could be a really easy solution for you. So that is all that I wanted to go over for today's webinar. regarding the interfaces between Revit and IFC and DXF. And now I would like to hand it back over to Amy to conclude the webinar.
Perfect. Thanks, Alex. So this presentation will be recorded and posted on our website, the same webpage that you used to register with the web link that was sent out through email. We'll also place the models that were used on that webpage as well as the PowerPoint. I know we had some issues today with the GoToWebinar platform and not being able to access that PowerPoint, so we'll go ahead and put on the website as well. Feel free also on our website to download the free 90-day trial version of RFEM. So the models that you saw today, you'd be able to open up within that free 90-day trial. It does include all add-ons such as steel design, concrete design, and so on, full capability for the 3 months. If you have any questions about today's presentation or anything else, feel free to contact us at our contact information shown at the bottom of the screen. You can see our phone number is 267-702-2815. That goes directly to our Philadelphia office, as well as our email, info-us@deluwald.com. We will have many more upcoming webinars. We'll begin with those at the start of next year. Approximately once a month, you can register on our website at deluwald.com under support and learning webinars. As most of you know, we will send out a reminder email about a week before these take place. So keep an eye out for that, again, beginning next month. PDH certificates will automatically be emailed to all participants who are here for the full presentation. That is a requirement of the states that we are pre-approved providers that you are here for the full duration of the webinar. If you by chance watched the webinar with a colleague or in a conference type setting and you yourself did not register under the GoToWebinar link, you will need to request that PDH at the email shown here, info-us@deluwald.com. Please just let us know who you watched it with. And again, if you yourself did not register for the GoToWebinar directly with your own name and your own email, you will need to request PDH here. And with that said, I want to thank everyone for attending today. And as always, we hope to see you at the next presentation. Thank you.